Okay, so here we go with extra credit number 5 for Math 201. In order to get full credit for these, you're going to need to write out the problem and then follow me with the solution. So you may want to put this on pause so you have time to write out the problem first of all. Okay, here we go. With this one, first of all, 6.5 hours means we're going to be using 6.5. The question asks, how much does he earn each hour? So this really means take how much he earned and divide by hours. So that means it's going to be $118.30 divided by 6.5. And then this particular extra credit is about using the calculator. So in order to do that, it's going to be 118.30 divided by 6.5. So sorry about my little bruise on the calculator. That would be $18.20 per hour. And another thing with these word problems is you should make sure that it's something that makes sense. For example, if I divided these and it said, let's say I got the decimal place wrong, let's say he made $1.82 per hour. So that is way below the legal minimum wage. I would not believe $1.82. Or if I forgot the decimal altogether, it would say $1,820 per hour, which is also not believable. But $18.20 per hour, that's believable. I can even label this per hour. Okay, then on to number 2. So the car is listed for $24,450. That price, I hope it's a new car. The dealer says he'll discount by 8%. Maybe you got the Costco special. 8% off. Well, there's 2 ways to do this. One way is what I showed you in class, and that is take the 24,450 and then multiply, and then 8% can be represented with the decimal 0.08. So multiply with 0.08. So 24,450 times 0.08, that means that the discount is $1,956 or $1,956. And then you take the original price of $24,450 and take off the discount, and then that's going to be the sale price. So then take the original price of $24,450, subtract the discount of make sure I remember it, 1956, and so the sale price is going to be $22,494. $22,494. Now, I haven't showed this in class, but here's a different and faster way to do it. When it's 8% off, that means you have to pay 92% of the price. So you just take 100% minus 8% is equal to 92%. So that means the person would have to pay 92% of the price. So here's how you could do it faster. Instead of doing all of this, you would just say the original price is $24,450 and the person has to pay 92% of that. So just multiply those. So 24,450 and the person has to pay 92% of that, and it's 22,494. 22,494 is the exact same answer, but it's a faster way to do it. All right, next up, number 3. So this worker can assemble 42 shirts every 2 hours. How many can they assemble after 5¼ hours of work? So 5¼ is the decimal 5.25 hours of work. And with this one, I can set up a proportion and say, okay, it's 42, and then I'll put shirts on top and hours on the bottom. And when you set up a proportion, you just have to be consistent. This should be shirts on top and hours on the bottom. And with this one, I'm given that it's 5.25 hours, so that would go right here. And then I'm trying to find out how many shirts, so I'll just use the letter X. After you set up the proportion, then cross multiply. So this would be 2x equals, and then this way would be 5.25 times the 42. And then I could figure out this right side is 5.25 times 42, so 220 and a half. 220 and a half. And then the last step is to solve for x, divide this side by 2, and divide this side by 2. And then this one, I think I could do without a calculator, because when you divide 2 into this, it's going to leave a 1, 1, 0. And then if this is 0.5, half of that is 0.25. 1, 1, 0, and 0.25. Now let's see if I did that right. So 220.5 divided by 2, 110.25. And then that would be how many shirts the person could assemble. Next up, number 4. So 8 ounces of chips is 14 grams of fat. How many grams of fat would be in 14 ounces? This again is going to be proportions. So here put ounces and here put fat. And I'm just going in order of the way the problem was given. Ounces first and then fat. So 8 ounces would be 14 grams of fat. Then I have to do the same here. Ounces on top, fat on bottom. Next, how many grams of fat? So fat will be X if it's 14 ounces of chips. And then cross multiply. So there would be 14 times 14 on one side. And then there would be 8 times X on the other side. Last time I multiplied this out first, and then I later divided. Well, you could do all of it at once. You could divide both sides by 8. So it's going to say X is 14 times 14, and divide that by 8. So I need to know how much is 14 times 14 gets divided by 8. And that way I need to just use the calculator once. 24 and a half. So then X would be 24 and a half. Oops, sorry, went off the screen. 24 and a half. And at the end, with word problems, you should label the answer. This, it was asking for fat, so this would be grams of fat. Next up, number 5, and with that, we're already halfway done. So this is another proportion problem. So in here, it said miles first and then minutes. So 7, and I'll put miles on top, and then 53 minutes. Then I just have to be consistent. Miles goes on top, and then minutes would be on bottom. So miles, minutes, miles, minutes. Okay, at that pace, in other words, the person keeps running the same pace the whole time. How long would it take her to run 26.2, which is a marathon? So this is miles, 26.2. And then how long means we're looking for how many minutes, so put X right there. And then cross multiply. So one side would say 53 times 26.2. Sorry. And then 7x. And like the last one, I'm going to save the calculator work and do it at the end. So this part, I'll just leave it like that. The next thing to do is to solve for x, divide by 7 on both sides. These will cancel, so it says x equals however much 53 times 26.2 divided by 7 is. So 53 times 26.2, and then I divided both sides by 7. So it's 198.371. So x is equal to 198.371, and then this would be minutes. So in order to check and see if this is reasonable, I could say, well, 60 minutes is an hour, and if the person ran for 3 hours, that would be 180 minutes. And then this is about 18 minutes more than that, so this would be approximately 3 hours and 18 minutes, which is actually a reasonable time for a marathon. See, if I did something wrong and it said 1.98 minutes, or if it said 19.8 minutes, there's no way a person can run 26 miles in 1.9 or 19.8 minutes. But 198 minutes, that's possible. Next. So this one is just division. You don't have to do a proportion. So it's just saying, this is saying divide them. So divide the cost, $1.39, and then divide by how many ounces? 16 ounces. So that one is just $1.39 divided by 16 ounces, 0.087. So the answer would be 0.087, and then since this is in dollars, this would be dollars per ounce. But usually with a price like this, you would not put it in dollars, you would put it in cents. So if you move the decimal over by 2, it would then be in cents. So it's actually 8.7 cents per ounce. Okay, we're 6 out of 10 done. Then for number 7. So with this one, it's 5.5 hours. So for that, I'll be using 5.5. That's the hours, and then I need to find the total amount of miles that were driven. So what I'll need to do is take this number and then subtract this number. So 35,777.7 minus 35,355.6 to find out how many miles were driven. And this one I could do without a calculator. This would be a 1, this would be a 2, this would be a 2, this would be a 4, and then this is 35 minus 35, so that's 0. So in other words, they drove 422.1 miles. Now the speed of the car is going to be in miles per hour. So that means that you have to take the miles, and then per means divide. So divide by 5.5 hours. And when we divide those, that's going to be the miles per hour. Okay, so I need 422.1. So I need 422.1 divided by 5.5. So that would be an average speed of 76.745 miles per hour. So that's actually pretty fast. That person was actually probably breaking the speed limit, but maybe they were in Montana or somewhere where they don't have a speed limit in some parts of their state. Okay, next up, number 8. So this guy went to the gas station and got 22.3 gallons of gas. And if it's $2.55 for each gallon, we just need to multiply. So 22.3 gallons of gas that cost $2.55 each. And if you multiply these, 22.3 times 2.55, so it would be $56. And then the thing is, when you go to pay for your gas, you're not going to pay 0.865. So this actually needs to be rounded. This 5 is going to round this up to an 87. So it's going to be $56.87. $56.87. And that would be the total. And now for the last two. So this one is describing a proportion. So 48 out of every 100 is a male. So that means there's 48 male people out of every 100 students. Then for the proportion I need to be consistent, up here would be male, and then here would be students. So currently, according to Hartnell's website, currently there are about 13,500 students. How many are male? So that's going to be X. Once you set up this, cross multiply, so that would be 100x is equal to 13,500 times 48. And then divide by 100, divide by 100. These are going to cancel, leaving just x equals this number. And with this one, I could go ahead and reduce. When you divide by 100, it's actually going to get rid of these two zeros right here. So really, I need to know how much is 135 times 48. So how much is 135 times 48? So that would be 6,480 of the students would be male. So a slightly faster way that you could do this one is 48 out of 100 means 48%. So you could just say 48% as a decimal is 0.48 and multiply that with 13,500 and you get the exact same thing. And then finally for number 10. So back to the gas station, but this time the total amount of gas is $42.90. How much did it cost per gallon? So per gallon means that I'm going to be dividing. So the cost divided by the gallons. So I need the cost, $42 $2.90 per 18.5 gallons. And then when I'm done, it's going to be the dollars per gallon. So when I divide these two, I would imagine with today's gas prices, the answer would be around $2.50, $2.70, something like that. If this turns out to be $12 per gallon, I probably did something wrong. If it turns out to be 12 cents per gallon, well, we're not in Venezuela, so that's not possible, 12 cents per gallon. If I get something around $2.50, that's believable. All right. 42.90 divided by 18.5. So that would be, when you round this 9, it's going to round this up to a 2. So it's $2.32 per gallon. So according to today's gas prices, that's a pretty good deal. That's reasonable. $2.32. All right, so that's it.